Okay, now let's take a look at an example of working with a public exploit that we find online. So if you did your exercise with 3Com, you should have a working exploit in Python. But we're going to take a look at an exploit in Perl that is written for a different platform. So if we go to exploit database, so exploit-db.com, and then exploits, and it's 3,388. So here's the URL up here. This is an exploit for our 3Com, and it is tested on Windows 2000, and we of course have Windows XP Service Pack 3. And it is also written in Perl, which we may or may not be familiar with the Perl programming language. So let's go ahead and download this exploit code and save it. And let's just put it on our desktop. So 3388.pl. So we also have it here. We can look at it in the browser, or we can look at it here. So Perl is going to be a little bit different. We have semicolons, indentation doesn't matter, things like that. So the main things we need to do is change this so it meets our operating system's needs. So we probably are going to have to change the return address. We have jump 2000 as the variable name, and it says a jump ESI in user32.dll Windows 2000 SP for English. And so we're probably going to have to change that. User32.dll probably changes a lot between operating system versions. So we could find a jump ESI in user32.dll on Windows XP Service Pack 3, even if we didn't have access to the 3Com service, which of course we do, but assuming we didn't, we could use a different program to look at jump ESIs in user32.dll. We also have shellcode. As I mentioned when we first looked at Metasploit earlier in the class, we should always, as a matter of thumb, regenerate our shellcode, since we can't read it just because it says it is a bind shell generated with Metasploit. We can't just assume that's true, so we should regenerate that. And it says it's 344 bytes. If it didn't say that, we could do a little bit of coding to get the length of that string pretty easily. And if our new shellcode that we generate is longer or shorter, we would need to change the offsets in our exploit accordingly. It also has something called nops. So we have a variable called nop, which is 90 in hex, and it's 129 of them. 90 in hex is a nop, or no operation. Basically that says do nothing and move on to the next instruction. It's fairly common to see nops in exploits. Basically, you jump to the beginning of the nops and slide down what is called a nop sled until you reach your shellcode. So it's a common way of doing padding. We've been a bit more precise. I used to use nops all the time, but then I was taught not to, so now I teach people not to. So there's no reason we can't be precise about where we're going to land. So there's no reason we have to use the nops, but if you do work with public exploits, you'll probably see some nops, so it's worth knowing what they are. So what we'll do is, based on how long our shellcode turns out to be, we'll change the length of the nop sled. So if we look at our exploit 02, so that's our opcode again, so it's going to write, file name is A, then there's our null to finish the file name, then we have our nops, followed by our shellcode, and then our jump. And if you did the exercise, you saw that the offset was 473, I believe, yes, is the offset to EIP. So our nops plus our shellcode together should be 473. Since our jump is after the shellcode, we need to be very precise about that, otherwise our jump won't end up in EIP and our exploit won't work. So we definitely need to make sure our offsets stay correctly in place by changing the length of the nop sled if necessary. So none of this seems like it's going to be too hard. That's Wrong VM, we need that VM. And so, what we can do, pretend like we don't have 3Com. I have 3Com here, but let's pretend like we don't have it. And turn back on War FTP. And need to get rid of that FTP daemon file. Put it online, attach to it in the debugger, and attach to it and let's do Mona JMP for jump and set the register to ESI. You can also have it automatically take out null bytes, because remember 3Com does have a bad character, just the one of the null byte, so we could have taken that out as well. So if we go to C and then logs or FTPD, then we have our new jump here, and we know that user32.dll is loaded on our 3Com, so if we look for user32, there's one right here, a jump ESI in user32, so we can change our jump open up 3388.pl and find our jump 2000 variable, and in little Indian format, of course. I don't know why I'm not being able to copy right now. Edit, copy, edit, paste. There we go, that worked fine. Okay, remember little Indian format, so 7E needs to go last, then 5A, rather 4-5, I missed a character, 4-5, AE, and 4E. So little Indian format is still necessary. I just put that there for reference, so I'll get rid of it. So that was pretty easy. So even if we didn't have access to 3Com itself, we could do that. Just find out where user32.dll has jump ESIs using another program. Now we need to regenerate our shellcode. So we can do an MSF Venom payload. Let's do Windows shell bind TCP again. And bad character is just the null. Size is 473 or less. And format needs to be Perl. Let that generate. I'm not going to grab my and buff equals because it's called my shellcode, I believe. So I will just grab the actual shellcode. Like dot is concatenation in Perl, and it does have a semicolon at the end, so it is in Perl format, making it a little bit easier for us. This is the one time I like to use VI, actually, is to get rid of multiple lines. 3388.perl. I'm just going to get rid of the shellcode that's already there using DD. And save it, and then go to Nano, where I would prefer to be. And under my shellcode, I will paste in my new shellcode. That looks good. So the last thing we need to take care of is our offsets. So if we move up a little bit, it says 368 is our length of our shellcode. And if we look back at the shellcode that was there, it said it was 344 bytes. So 368 minus 344, that's 24. So it looks like we've got 24 more bytes of shellcode than the original exploit. So again, to make sure our offset is correct, we need to adjust the length of the knob sled accordingly. So 129 minus 24, that's 105. See, I can do a little bit of arithmetic. Alright. So we did regenerate the shellcode. We adjusted the length of our knob sled. So we had the offset staying the same. So our jump 2000 variable, which is our jump ESI, still be at 473 bytes into the attack string. So it will end up in the IP and will be executed. Otherwise, we'd end up with a crash probably. So those are the only things we have to change. Really, we just need to regenerate our shellcode always, because we can't read it, and we need to make any adjustments for the platform. Particularly, we need to change the return address to meet our platform needs. So, pretty simple. So let's go ahead and make sure that our 3COM is running. We did the start service again. That is in C Windows, and it is the blue and white 3 to open up the controller, and then just hit start service. So it may still be dead from you working on your exploit. Alright, so let's run this. So Perl 3388.Perl, and it says it needs host and port. So we need IP address of XP, and the port 69. And we did do a bind shell, so this should work. Yay! See Windows System 32. So since this is a system service, we get a bit more privileges here. Naturally, we became system instead of just with WarFTP. We became the user Georgia who started it, so that's nice. So, you know, public exploits can be nice from time to time. That one wasn't too hard to change. So, not too bad there. Let's see if we can turn it into a Metasploit module.